Alright, this is our second video, and we're going to be focusing on Chapter 7, Lesson 8. The Common Core State Standard is to apply and extend previous understandings of multiplication and division to multiply and divide fractions. The interesting part about this lesson is that we're not really going to be creating diagrams, nor are we really going to be solving any equations. This one's more conceptual understanding of what multiplication really means. So when we're talking about compare mixed number factors, factors are the numbers that you're multiplying. So the factors for this would be 5 over 5 and 2 and 3/4. The factors of this would be 2/3 and 1 5/8. So the factors are the two numbers that you're multiplying. And when we're talking about products, the products is the answer to a multiplication problem. So we're going to be comparing what are the numbers that we're multiplying and how does that relate to the answer that we'll be getting, the product. Before we could really start this, we need to know what multiplication is. So I'm going to be going back and forth from whole numbers to understand the concept of multiplication to this actual lesson, which applies fractions. In class, we've said several times, multiplication is repeated addition. And I'd say, class, what is multiplication? And they'd repeat, multiplication is repeated addition. But let me really break down what that means. Let's say we're doing a problem such as 5 times 3. If I were to ask you what is 5 times 3, you'll probably tell me 5, 10, 15. Miss Soltino, 5 times 3 is 15. Like I said, in this lesson, we're not really finding the answer to anything, the product, nor are we drawing any pictures. We're understanding what is multiplication. So now, if I were to retort back to you and ask, okay, what does that mean? You could tell me multiplication is repeat addition, so show me. You could be repeating the number 5 3 times. So you could say 5 is being repeated 1 time, 5 is being repeated 2 times, and 5 is being repeated 3 times. Remember, multiplication is repeated addition. So we're going to put an addition sign in between these. We're repeating the number 5 1, 2, 3 times. And if I think about my touch math right here for a second, I'm going to add these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. 5 plus 5 plus 5 is 15. The 5 is being repeatedly added 3 times. We could also do another kind of addition problem. A second addition problem we could do is saying the 3 is being repeated 5 times. So you could say 3 is being repeated 1, 2, 3, 4, 5 times. And multiplication is repeated what? Repeated addition. So we're going to put an addition sign in between that. So the number 3 is being repeated 1, 2, 3, 4, 5 times. And looking at the touch math for 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is what I mean, that multiplication is repeated addition. We're using these factors, and this is the product. So this is a factor, and this is a factor. And the answer to the multiplication problem is the product. It's very important that we keep in mind that we're going to label these things even on our homework. So let's take a look back at what our lesson is actually focusing on. it says, complete the statement with equal to, greater than, or less than. The important thing that you need to know is all of these answers are not asking really for a drawing. They're not asking for the answer. In each of these blanks, there are only going to be 3 answers. The 3 answers will either be equal to, greater than, or less than. Okay. Now, for each of them, they start off with a multiplication problem. They start off with a multiplication problem, multiplication problem, multiplication problem. What I want you to do is do exactly what I'm doing and draw a square around each multiplication problem. It's not quite a square, so much as it is a rectangle. Okay. Having done that, we are going to compare mixed number factors and products. So we're going to compare, see whether something is equal to, greater than, or less than the factor or the product. So what they're saying in this sentence is that this product, this answer, will be less than, greater than, or equal to this factor. Now this is not just some random number. It's one of the factors or numbers that you're multiplying. What I want you to do now that you've squared or put a rectangle through every multiplication problem, I want you to show me what factor they're associating it with. So here, the factor is that you're going to be comparing is 2 3/4. The factor that you'll be comparing is 2 3/4. The factor is here, and it shows up here. Right now, you can see that a lot of them are the second factor. That might not always be true though, so keep your eyes peeled to see if there's any changes. This one's going to get interesting. 3 4/9 is actually one of the first factors. So, what they want us to do is if we're to solve this answer, this product, if we're to solve each of these products, will it be less than, greater than, or equal to one of the factors that they're being associated with? Before going with fractions, let's see if we can make sense of it with our numbers right here. I'm going to copy the same exact sentence frame as this, but using the numbers 5, 3, and 15, because it's something we're familiar with now. So, they had the multiplication equation. Let's use our multiplication equation. 5 times 3 will be blank. And remember, our possible answers would be equal to, greater than, or less than one of the factors. So, since most of them are going to be the second factor, let's try doing the second factor. 3. Before I continue, I want you to see the sentence frame. This product, the answer to 5 times 3, will be, and here we have to solve, it's either going to be less than, greater than, or equal to one of the factors. If we could solve this one with whole numbers, you better believe we could do the same thing when it gets a little bit more complicated with fractions. So let's solve this. We know that 5 times 3 is 15, and 15 will be greater than 3. That makes sense. Now the reason why we know that is that their whole numbers, 5 times 3 is 15. 15 will be greater than 3. They're asking for this answer or this product, will it be greater than or less than one of its parts, one of its factors. The hard part when it gets to here is that we're not trying to solve 2/3 and 1 5/8. We're trying to make sense of it. So the reason why I'm slowing down and making sure we make sense of it is what they want you to do, instead of solving it and finding out 15, is using logic. Since the number 3 is the number we're going to repeat it, we're going to repeat it 5 times. So here we're going to do 3 plus 3 plus 3 plus 3 plus 3. Because the numbers are getting bigger, that's why it'll be greater than 3. Does that make sense? Because 3 is being repeated 5 times. The number, when you're adding by whole numbers, it gets bigger. So that's why it's greater than 3. And let's see if that kind of makes sense with this. What's happening here? We're looking at 1 and 5/8. Now, if we start with 1 and 5/8, and we're repeating it only 2/3 of a time, that's saying that you have 1 and 5/8, but you only repeat it. You only repeat it 2/3 of a time. Remember, that second factor is how many times you repeat it. So if over here you're repeating it only 2/3 of a time, 2/3 is less than 1. What this is saying is you have 1 and 5/8, and you're repeating 1 and 5/8 only 2/3 of a time. If you have, on the number line, 0, 1, 2, and let's say you have 5/8, here's your half. Those are 4. If I split all of these up, now you have 5. If you have 1 and 5/8, you're roughly around here. You don't even have all of that. You only want 2/3 of it. Here's your 1 and 5/8. You only want 2/3 of it. So you're going to take this one, split into thirds, and you're only going to have a part of that. So your final answer will be less than what you started with. If you have 1 and 5/8 and you want to repeat it 2/3 of a time, you're repeating it less than 1. You're going to have less than what you started with. Ready to move on? Let's try the next one. This one. We are repeating 2 and 3/4. How many times are we repeating 2 and 3/4? We're repeating it 5/5. What is 5/5? If you have 5 pieces of something, I do 5 by making a person. Here are their hands, their legs, and then the head. If you have 1, 2, 3, 4, 5 pieces of it, you have 1 whole. When the numerator is the same as the denominator, it equals 1. So if you multiply anything by 1, 1 times 100 is 100. 1 times 7 is 7. 1 times Miss Tolentino is Miss Tolentino. So 1 times 2 and 3/4 will equal 2 and 3/4. 2 and 3/4 will be equal to 2 and 3/4. Anytime you multiply by the number 1, or something that's equivalent to 1, such as 5/5 is 1, it's going to be the same number. I hope you're seeing a pattern here. If the number you're repeating is less than 1, your product will be less than 1. If the number you are repeating, the amount of times is going to be, not the number you're repeating, but the amount of times you're repeating it is going to be 1, it equals to 1. Let's see the next one. 3 and 2/7 is the number you're repeating. 3 and 2/7. You're repeating it 3 times. So you're going to have it 1 time. You're going to have it 2 times. You're going to have it 3 times. What's happening to the 3 and 2/7? Is it getting bigger, smaller, or is it staying the same? It can't be staying the same because they're 2 different numbers and you're adding to it. So definitely it's not equal to. It's not getting less because you're adding 3 plus 3 already at least at the whole number, so your number is going to be more than 6, more than 9. So it's definitely getting bigger, greater than. Now I'm going to let you try to figure out the next ones on your own. But keep in mind, the number that you put an arrow to for all of these, that's the number you're repeating. The number to the side of it will tell you how many times you're repeating it. If the number of times you're repeating it is less than 1, your answer will be less than 1 because you have less than what you started with. Think back to the pictures that we drew when we said we had 28 Pokemon cards. 3/4 of those Pokemon cards are water Pokemon. How many water Pokemon do you have? Well, if 3/4 of the water Pokemon that you have, the Pokemon cards you have are only water, then you can't have more than 28 Pokemon cards. 3/4 means you don't have the whole thing. 3/4 means you have less than the amount. That's kind of what's happening here. If what you're repeating, the amount of times you're repeating it is less than 1, then this product is going to, the product is going to be less than the factor. Blah. All right, I hope that one kind of makes sense. This one is a little more conceptual. If worse comes to worse, what you could always do is just solve the problem like we did over here. We solved it and said 15 is greater than, less than, equal to the actual number. So if worse comes to worse and the conceptual still does not make sense, then my recommendation to you is to tell you just solve it. Just go for it. Solve it with pictures. Solve it through multiplying using what we learned yesterday with the area models or whatever floats your boat. And then just compare your answer here to this. If you can get the conceptual understanding of it, that would be best. Keep in mind, the number that you have at the arrow is the number you're repeating. The other factor is how many times you're repeating it. If that other factor is less than 1, your answer is going to get less. If it's more than 1, your answer is going to get bigger. It's going to be more than 1. And if it's exactly 1, it'll stay the same. I hope this lesson helped, although sometimes I use the wrong terms and I do apologize. You guys will do better on Friday. Have a good day. All right, word problem time. Now, after we read through this, just keep in mind, all we're doing is changing English to Math English. We're changing these words into a mathematical equation or equations. Fraser, I'm guessing is how to pronounce the name, but this is a name. Fraser is making a scale drawing of a doghouse. The dimensions of the drawing will be 1/8 of the dimensions of the actual doghouse. Dimensions are just another way of saying like units, so like length or width and height. So the height, which is how tall something is, of the actual doghouse, is 36 and 34 inches. Will the dimensions, which they mean in this case because they mentioned height, will the height or the dimensions of Fraser's drawing be equal to, greater than, or less than the dimensions of the actual doghouse? Phew! There's quite a few words here, but let's slow it down and see. Will the dimensions of the Fraser's drawing be equal to, greater than, or less than the dimensions of the actual doghouse? So by looking at this, I see that something will be blank, less than, greater than, or equal to something else. So we're going to use this sentence frame here. Looking at the sentence frame, we're going to need some kind of mathematical equation that we need to solve. We're going to need something that will be greater than, less than, or equal to some other number. Okay? So that's going to be our template. Sorry, it's hard holding a camera and trying to write at the same time, but that should be 2 words, okay? Keep that in mind. Will be. For our multiplication expression, let's see if we could find it. The dimensions of the drawing will be 1/8 of the, reminds you to multiply, 1/8 times the dimensions of the actual doghouse. We're going to have to change this phrase into a math number. How can we find the math number? Let's read through this again and see if anywhere in this paragraph it tells you the dimensions of the actual doghouse. Because instead of reading of the actual doghouse, you could put the number of the actual doghouse there. So we're looking for the height of the actual doghouse. Let's read it again and see if we can find the height of the actual doghouse. Fraser is making a scaled drawing of a doghouse. The dimensions of the drawing will be 1/8 of the dimensions of the actual doghouse. The height of the actual doghouse is 36 3/4 inches. Will the dimensions of Fraser's drawing be less than or equal to blah, blah, blah? So over here, it says that the actual doghouse is 36 3/4. So in here, we could put that number, 36 3/4. Now we were able to find our multiplication problem. The dimensions of the drawings will be 1/8. So that's how we're going to start the math problem. 1/8. Instead of saying the, we're going to put the multiplication sign. The dimensions of the actual doghouse, and it told us the actual doghouse, which is 36 3/4. 36 3/4. All we did was we took these sentences and turned it into a mathematical equation using context clues. It told us specifically it will be 1/8. That's where we got the 1/8 of the. We used that for the multiplication. The actual doghouse, they told us the doghouse is 36 3/4. We have our multiplication equation. Then we have our will be. So this right here is the dimensions of the drawing. So if you imagine a doghouse, it's a lot bigger. If I want to draw the doghouse, of course it's going to be smaller. So this number will be what? Let's finish this off. Will the dimensions of the Fraser's drawing, here's the drawing, be equal to, greater than, or less than, that's what this one will be, the actual doghouse. So this number right here is going to be the actual doghouse. They told us that the actual doghouse is 36 3/4. Actual doghouse is 36 3/4. So look at this. Will the dimensions of Fraser's drawing, this is the drawing, be equal to, greater than, or less than? Will be equal to, greater than, or less than the dimensions of the actual doghouse. The dimensions of the actual doghouse. So like I said, it's just changing this into a mathematical equation. 1/8 of the doghouse. Will the dimensions of this drawing be greater than, will be greater than, equal to, or less than the actual doghouse? And it follows this format right here. I'd like you to try to do something similar for number 8 in terms of setting it up and solving, and make sure to finish solving this. This will be solved the same way as the ones above, using logic or reasoning. If worst comes to worst, just solve the equation and compare your answers. Have a good day.